There are primitive and the object types. Primitive is an int type, maybe double, and etc. And the object type, for example, character. Object type is more difficult structures and which can contain another object types or primitive types. And one of the main differences is that primitive types are initialized with default values. For example, in character object we can see the int age field of type int. Int is a primitive type, and when we create a new character, its value is by default 0 because it's int. If it will be double, its default value was 0.0. If string with empty string in the etc., it is int. And when we create a new character Hermione, Harry, Draco, and Hermione, without age and without birth date, local date type age. And if we invoke from Hermione get age method to get Hermione's age, we can see 0. It is default value of int type. So we can get the 0, but if we change the primitive type to integer, this is class wrapper, this is object type of which corresponds of primitive int type, and run our program again, we can get the exception, null pointer exception, cannot invoke int value because this age is null. If it was int primitive type, it has initial default value 0. But if when we change it to object type integer, it have null by default, and we can get, and we must give it initial value to avoid null pointer exception. To add some logic, something look like if age is null, then return 0. We must return int type and 0. Okay, run our program. Now we can get a 0. This is the main difference between objects and primitive types. Also, there is a difference in storage primitive types and objects. Just create two primitive type. First primitive type is int, variable 1. It has 5 value. And int variable 2, which contain the value 5 too. So let's compare this. Variable 1, variable 2. Run our program. And we can get true, because 5 is equal to 5 of 5. Let's change 5 to 6. This true was true, and if we run our program again, we can get the difference result false, because 6 is not equal to 5. For primitive types, these compare by value, return true if the primitive type is equal, but this is not the same for object types. we can get these three object types. Create Harry, new character with name Harry Potter, age and local birth, Draco Malfoy, age and local date, and the Hermione only by name. You must understand that these objects, Harry, Draco, and Hermione, are not the objects themselves. They are only reference to real objects in memory. This is just reference to object of character type with these fields. So if we create other object of type character and just student and assign this value to here, so we suggest that this is the same objects, Hermione and the students. Let's comment this temporarily. But what happens if we will compare the subjects by value and run our program? We can get true. It means that this is the same object. So, but we suggest these different objects. For example, we can create Hermione and let's assign its value to student, and let's work with the student. Don't working until Hermione. Let's change its name, for example. Set name. We need the method set name. Character get birthday. Only get name. Let's add a setter. Alt insert a setter. No fields with a setter were found. So why? Oh, final. If we specify the field as final, it's constant and we can't change its value. Now this is not constant, this is not final variable, this is only variable, simple variable, and we can change its value. And let's add alt insert a setter for field name. Okay, and we can get we can invoke set name and change its value. Some other value of name. Neville Longbottom, for example. And we work only with the student and change name for student, not for Hermione. But if we will print the Hermione names, get name, we can see the next result. Hermione names is Levin Longbottom. No, that's incorrect. Hermione, we create a new object, assign this object to other object student, and change the name of this other object. But the name of Hermione is changed too. Because why? Because these both are the same object. So if we needed two different separate objects, we needed to invoke method copy. Use the copy method. So in order for this method to exist, you need to implement the clonable interface. Implements clonable Java link interface, and just override the method clone or copy. Clone. Protected object clone. And you must remember that this method from object class. Object.clone. This method, not from this interface. This is only marker interface, and it don't has any methods. Only marker interface for clonable. Protected object cloning, and let's create other object. type of character, and its name clone. From super is from object clone, and we must cast it. This is a return object. We must cast it to character. Parentheses and character in parentheses. Okay. And this is shallow cloning, but we need deep cloning. So from clone, we need to invoke these methods and get it result from implicit this exactly object of type character from this keyword dot h. For setting this value to this, we can get age, name, and birthday. A name from this dot name, birthday from this dot birthday, and return this class. This example of class character. Okay. It returns only object, so we needed to cast it here too. Character. So we know that this method throws clone not supported exception, may throw or may not throw, but here we must to add exception to method signature that this method too can throw clone not supported exception. Okay, run our program. And Hermione Granger names is Hermione Granger. That's right. And now, that's right. We create Hermione Granger. We can create a student from Hermione Granger by copy, clone, and change name for student from Hermione Granger to Neville Longbottom. But in this is a separate object. But in the Hermione object, the name remains the same. If we run our program, we can see Hermione Granger. Good job! See you in the next lesson.